Alrighty, just in case substitution was not fun enough for you, I'm going to do an example of a problem I pulled off of IXL in the I-9, which is the elimination method with the multivariable. So with elimination, keep in mind that you want to have matching so that they are equal but opposite pairs. And what that means is you might want to have a 2x and a negative 2x, or a 5x and a negative 5x, or so on. You're trying to get them to cancel out or eliminate. So you have to use all three of them. I like to look and see like which ones will match up the easiest. These wouldn't be bad because I could turn this 1y into 3 or 1y into 2. Same thing here. And I'd probably do these just because we're so used to working with x's. So I'm going to first take the top two and work with those and try to eliminate those x's. What I would do is I would leave the top equation the way that it is. And now I'm going to try to get that second equation to match and cancel out. And since it's currently a -1 and I needed to cancel this out, I need it to become a +3. So for this particular thing, I'm going to need to multiply this whole thing by a -3. Because then when I distribute, -3 times -1 will become a 3x, and those will eliminate, which is the goal. Then -3 here turns this into a +9y. -3 here turns that into a +6z. -3 here turns that into a 30. So I'm distributing that -3 to everything in there. And now when I combine the top two, so this was the top and this is the middle, but multiplied by that -3 to create this matching pair so that can eliminate. Here I end up with 11y. Here I combine to get -9z, and here I combine to get 25. So I just let that sit here for a little while because now I have one equation with only y's and z's in it. So now I have to also use the bottom equation, but again end up with just y's and z's. So the easiest thing there, I think, would be to use these two because it's easier to match and cancel these two x's than it would be the top and the bottom. So if I'm looking at these two now, I'm going to leave the bottom one the same. And now to get this one to cancel, I would need this -1x to be a +2x. So now I'm going to have to multiply this row by a -2. Because then -2 times -1 will become a +2x. -2 times -3 becomes a +6y. -2 times +2 becomes a -4z. And then don't forget this last guy. -2 times -10 becomes a +20. So now I've done the same thing. I can eliminate the x's. So I started off with 3 variables. Now I'm going to be down to 2. So this column combines to be 5y. This column combines to be -2z. And this column combines to be 26. So at this point, I've gone from having 3 variables with 3 equations. Now I'm down to 2 variables with 2 equations, and I'm going to keep funneling that down until I just get one equation with one variable that I can actually solve. So now I'm going to line these two up and see what's going to be the easiest way to solve these. Now, nothing is super obvious here, and I'm definitely going to need my calculator's help because I have to create an equal but opposite pair, and neither one is really lovely. It doesn't really matter, so I guess I would make both this 9 and 2 into an 18. To do that on the top, I'd have to multiply by 2. Distributing that, I'll get 22y. Here is a -18, and then don't forget to double that as well and get a 50. But in order for them to cancel, I need the bottom one to turn into a +18 here. And the only way to get -2 to be a +18 is if I multiply through by a -9, giving me -45 for y's. This is going to turn into the +18 that I need for the elimination. And then here, I'm going to have negative 9 times 26, which is apparently negative 234. So this is messy. Okay, these eliminate. That was the entire plan. These, I'm going to have 22 minus 45. So negative 23y equals, and then combining these, 50 minus, because it's a negative, 234, gives me negative 184. Yuck. But now I'll divide by negative 23 and hope for the best. So if I divide that by negative 23, yay, I got a reasonable number. And now I'm 1/3 of the way there, but I really have done the vast majority of my work. Keep in mind what goes where. So the y value is 8. That's my middle value. Now I'm going to go back and start looking for a place to plug that in. These two equations are going to help me find z based on y. You can use either one. I guess this one to me looks a little easier. So I would take my 5y minus 2z equals 26, but instead of the y, I'm going to go ahead and plug in the 8 that I think y equals. So then here I'll have 40 minus 2z equals 26. I'll take 40 away. So I'll have negative 2z equals negative 14. And so ultimately, when I divide by negative 2, z is 7. Okay, so don't forget that that's z, so it goes in the last spot. Now I know 2 of my 3 pieces, so I go all the way back to the top, and I'm going to use one of these to find my x. I like to plug in the one that looks easiest to use, so I'd probably grab the bottom one. It doesn't matter really, but I would take that. I'm going to go down here where I have some room. My negative 2x minus y plus 2z equals 6, and I'm going to put in the 2 things that I know. I know that y is 8 and that z is 7. So now I have this. This becomes a negative 8 and a plus 14. So combining these two, I get a 6. Moving that 6 over by subtraction, I end up with negative 2x equals 0. So my x is actually 0 as well. So these are my answers, and I'm going to go plug those back in at the top to make sure they work before I enter them. So these problems can get to be a little bit long. And so I, again, want to be really careful that I do them correctly so I can not have to go back and do even more questions to kind of hit my mark on IXL. Hopefully that is one example that can help you get a good start on I-9. Have a good night, morning, evening, middle of the night, whatever time of day you're watching this. Bye, guys.